you would see more dramatic changes in current as the device approached its thermal limits. And you certainly wouldn't want to approach Curie temperature with this because you would get a thermal runaway situation. And again, they're the properties. This is the Steinmetz loss. And it was interesting that with a power ferrite, the designers or the manufacturers minimize the losses at a certain temperature, a certain elevated temperature, and maybe I can show that more clearly by this graph. This is a 3D graph of the core loss with varying by the V and by the temperature. The V is the flux density and the temperature. And I have temperature across here on the front axis and flux density, peak flux density on this axis here. And you can see that there is a minimum of core loss around about 90 Celsius, where the manufacturer of this ferrite would expect us to run. He's minimised the core loss. I guess he's done that by changing the components and the crystal structure and so on. So that's going back to XLD's a 1D version of that, and the minimum there, you can see it's around about between 80 and 100 Celsius is the minimum core loss, going out to 0.4 Tesla on this power ferrite. Probably wouldn't run a power ferrite at 0.4 Tesla, you would limit it to 0.3 Tesla or so in practice.